Ever stop to think about how your phone unlocks just by looking at you? Or how Netflix or YouTube somehow just know exactly what you want to watch next? It feels like straight up magic, right? Well, it's not. It's something way more interesting. So let's pull back the curtain on the hidden world of machine learning that's pretty much running our lives.
This really just nails it, doesn't it? Seriously, think about it for a second. Your phone recognizing your face, YouTube feeding you that perfect video. It's not some wizard behind a curtain. It's this powerful, invisible engine running the most personal parts of the technology we use every single day. Okay, so we've established it's not magic. Fair enough. But then what in the world is it? How does your phone, a little device in your pocket, learn to do these absolutely incredible things? Let's get into it.
So here's the absolute key. In the old days, a programmer had to write endless lines of code, like if this happens, then do that. With machine learning, we kind of flip that on its head. We don't give the computer rules. We just feed it a ton of data and let it figure out the patterns all by itself. It literally learns from experience, a lot like we do.
And boom, this brings us right back to our daily routine. That face unlock on your phone? It wasn't programmed with your face. It learned your face from data. YouTube isn't guessing. It's learning your taste from every video you watch. Your email catching spam. It learned what junk mail looks like by seeing millions of examples. It is absolutely everywhere.
That's a really good question, right? I mean, the basic idea of machine learning has been around for decades. So why is everybody talking about it now? What's the big deal all of a sudden?
Well, the answer is all about scale. Just look at this first bar. The amount of data we're creating every single day is, well, it's astronomical. Now look at the other two bars. There is no way a human, or even a team of humans, could possibly sift through all that. We are physically too slow. We need machines that can chew through this data at lightning speed to find the useful patterns.
Okay, so machines learn from data. We get it. But what does that actually look like? How do you go from just a giant pile of raw information to a smart, useful prediction? Before we even get into the fancy steps, we have to talk about the golden rule, the #1 most important law in all of machine learning, and it's this: garbage in equals garbage out. It means your final result can only be as good as the data you start with. If you feed it junk, you're going to get junk back. Simple as that.
So here's the typical game plan. It all starts with data collection, just grabbing all the raw info like, say, your YouTube watch history. Then comes the really important part, data cleaning. You got to fix all the errors and typos. After that, you select your features, the most important bits of info, like how long you watched the video or its genre. Then you can finally get to training, where the machine just practices and learns. You test it to see how well it did, and if it passes, it's finally ready to make a prediction about the next video you're going to love.
Now here's where it gets even more interesting. It turns out learning isn't just one thing. Depending on what kind of data you have and what you're trying to do, machines can actually learn in 3 completely different ways. And the main difference between the first 2 ways of learning comes down to the data itself. Is it labeled or is it unlabeled? Labeled data is super neat. Every single piece has a tag on it, like an email that's clearly marked spam or not spam. Unlabeled data is the Wild West. It's just a huge, messy collection of info with no tags at all.
So method #1 is called supervised learning. And honestly, the best way to think about it is like a student studying for a test with the answer key right in front of them. The machine gets to see thousands of examples that are already labeled correctly, and it just learns the patterns. So when a new email comes in, it can make a really good guess based on everything it's already seen.
Unsupervised learning. Now this is where it feels like real detective work. Here, you give the machine that big, messy pile of unlabeled data, like a company's customer shopping history, and you just tell it, go find something interesting. Its job is to find hidden patterns and clusters all on its own, maybe discovering groups of customers you never even knew existed.
And that brings us to the third and maybe the most dynamic way of learning. It's all built around this really simple, powerful idea. You get punished for messing up, and you get rewarded for doing something right.
This is called reinforcement learning. Imagine an AI learning to play a video game. It has no instructions, no answer key. It just plays. Every time it gets a high score, it gets a virtual reward. Every time it loses, it gets a penalty. And after doing this millions and millions of times, through pure trial and error, it eventually figures out the perfect strategy to win. This is the exact same logic that helps self-driving cars learn how to navigate a busy street. So, we've covered the what, the why, and the how. Let's bring it all back home and look at where machine learning is actually making an impact in the world around us, from how we shop to how we stay healthy.
Now, that whole how part involves different algorithms, and you can just think of algorithms as specialized tools in a toolbox. You wouldn't use a screwdriver to hammer a nail, right? Same idea here. You'd use a tool like linear regression to predict something like house prices, but you'd use a different tool like k-means clustering to find those customer groups we talked about.
And this chart really puts it all into perspective. I mean, sure, a huge chunk of it is in our daily lives, our phones, our entertainment. But look at the other slices. It's fundamentally changing huge industries. It's helping doctors spot diseases earlier in medical scans and helping banks detect fraud in real time. This is a massive shift.
But this whole revolution didn't just pop up overnight. The core question, can machines think, was asked by the legendary Alan Turing way back in the 1950s. For decades, though, it was mostly just theory. The real explosion, as you can see, happened in the 2010s. That's when the two magic ingredients finally came together. Oceans of data and the super powerful computers, the GPUs, needed to process it all. And that brings us to today, and more importantly, to tomorrow. So where is all of this going? What does the future of machine learning actually hold?
Well, it's really important to see both sides of the coin. The advantages are just mind-blowing. Automating boring tasks, getting incredible accuracy, and making sense of huge data. But there are real challenges. These systems need a lot of data to work. They can be a nightmare to fix when something goes wrong, and the hardware to run them can be seriously expensive.
I think this is a really healthy and probably accurate way to look at the future. The conversation isn't really about replacement, it's about collaboration. The goal is to build amazing tools that boost our own intelligence, that help us solve problems that were just too big for us to tackle on our own.
And let's end on this thought, because it's so important. This stuff is not some far-off science fiction idea anymore. It's here. It's now. It's already shaping our jobs, our economy, and our lives. Understanding it today is what's going to put you ahead of the curve tomorrow.
So the final question really is for you. This change is already happening, right now, all around us. Are you ready for what comes next?